Welcome to Chapter 3. Chapter 3 is all about exponentials and logarithms. Exponentials and their inverses of logarithms. We'll be starting about exponentials. So it's a function, f of x or y equals a to the power of x, where x is our exponent. So we're going to start off with a little bit of calculator practice. F of x equals 2 to the x. So f of negative 3.1 equals 2 raised to the negative 3.1. Make sure you use parentheses around your exponent, and you're going to find out that that equals about 0.1166. F of pi for number 2, it's going to be 2 raised to the negative pi. And your calculator should have a pi button there, and you're going to get about 0.1133. This is all about calculator practice. So make sure you're practicing on your calculators. For number 3, f of 5 over 7. 12 to the 5 over 7, make sure you use parentheses around your exponent. And you're going to get about 5.899. And then f of 3 halves is going to be about 0.6 raised to the 3 halves. Make sure you use those parentheses. 0.4648 is your value. Like I said, it was all about using your calculator to practice typing those exponents. Now we're going to graph. We're going to make a table of values. And we're going to pick a couple of values around 0. Negative 2, negative 1, 0, 1, 2. And I'm actually going to go to 3 for my x. So what I have is 2 to the negative second, 2 to the negative first, 2 to the 0, 2 to the first, 2 squared, and 2 cubed. Now I'm going to start with 2 to the 0 because that's one of the easier ones. Any non-zero number to the 0 power is 1. 2 to the first is 2. 2 squared, 4, and 2 cubed is 8. Now the negative exponents. Negative exponent means reciprocal. So it's 2 to the negative first, which is 1 over 2. 2 to the negative second is 1 over 2 squared, which is 1 over 4. So we have negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, 4, 8. Now, exponentials have an asymptote, a horizontal asymptote. And our horizontal asymptote is going to be at y equals 0. We talked about this in Algebra 2 last year. No matter what our input is, we're never going to get 0 for y. We're going to get close to it, but never quite get there. So this is the shape of this exponential function. So now, this is what we call a growth function. It's rising from left to right. Now, our domain is all real numbers. We're going from negative infinity to positive infinity. And our range, we're going from 0 to infinity, but we're not ever reaching 0, so we use a parentheses to infinity. And our horizontal asymptote, I'm going to use HA for short, y equals 0. For number 6, 2 to the negative x. Now I'm going to start at negative 3, negative 2, negative 1, 0, 1, 2. So what we have here is 2 to the opposite of negative 3, and that's actually just 2 to the third. So 2 to the opposite of negative 2 is 2 squared. 2 to the opposite of negative 1 is 2 to the first. 2 to the opposite of 0 is 2 to the 0. 2 to the negative first and 2 to the negative second. So we saw these values already. 2 to the third is 8. 2 squared is 4. 2 to the first is 2. 2 to the 0 is 1. 1/2, and then 1/4. Once again, no matter what our input is, we'll never get an output at 0 or below it. So our horizontal asymptote's at y equals 0. So our graph is going to look like this. It's going to fall from left to right. So we call this a decay function. Our domain, all real numbers, we're going from negative infinity to positive infinity. Our range, we're going from 0 with a parentheses up to infinity. And our horizontal asymptote is at y equals 0. All right, let's do some more. Next page. 4 to the x. Make a quick table, -2, -1, 0, 1, 2. I'm doing this by hand because I want to practice with my exponents. 4 to the negative second, 4 to the negative first, 4 to the 0, 4 to the first, 4 squared. 4 to the 0 is 1, 4 to the first is 4, 4 squared is 16. 4 to the negative first is 1/4, and 4 to the negative second is 1 over 4 squared, which is 1 over 16. You can see that's the reciprocal of 4 to the second, 1 over 16. Once again, horizontal asymptote, y equals 0. And it's going to go straight up. So we would call this a growth function. The domain is still negative infinity to infinity. Our range, starting at 0 and going towards infinity. And our horizontal asymptote is at y equals 0. It's that horizontal line. Number 8, 4 to the negative x this time. That's just the reciprocal of the previous one. So it's 4 to the opposite of -2, 4 to the opposite of -1, 4 to the opposite of 0, 4 to the opposite of 1, 4 to the opposite of 2. So it's going to be 4 squared, 4 to the first, 4 to the 0, 4 to the negative first, and 4 to the negative second. So it's the reciprocals. 16, 4, 1, 1/4, 1/16. So you can see what's going to happen here is it's going to start up here. Horizontal asymptote still at y equals 0. And it's going to fall from left to right. So because it's falling from left to right, we call this a decay function. Our domain, going from negative infinity to positive infinity. Our range is going from 0 towards infinity. And our horizontal asymptote is at y equals 0. Now, the one thing I want you to keep in mind for these, the horizontal asymptote for both is at y equals 0. The domain, all real numbers, negative infinity to infinity. Our range was going from 0 towards infinity. Our intercept, the y-intercept, is at 0, 1. For the x-intercept, there is none. And that's for our basic graph of y equals a to the x and y equals a to the negative x. Now, a to the x is growth. See how that exponent's positive? Negative x, see how that exponent's negative? That's decay. Let's go to the next page. We'll be doing more of these graphs as we go through. What we're going to do is we're going to talk about solving some exponential functions to finish up. So we have what's called the one-to-one property. So if you look, a to the x equals a to the y. If the bases are equal, then the exponents are equal. Then x equals y. And it goes vice versa. If x equals y, so if the exponents are equal, then the bases are equal. Now here, my bases aren't equal. I need to rewrite this. Now, 9 is the same as 3 squared. So I can write 9 as 3 squared, and that equals 3 to the x plus 1. Now, I have my bases equal to each other. So once my bases are equal, my exponents are equal. Then 2 equals x plus 1. So then when you subtract 1 from both sides, x equals 1. And you can see that's true. 9 equals 3 to the 1 plus 1. 9 equals 3 squared. 9 equals 9. It worked. 1/2 to the x. Now, I can rewrite both of these. 1/2 is the same as 2 to the negative first raised to the x power. And 8 is the same as 2 to the third. To rewrite using my exponent rules, power to a power we multiply. So it's 2 to the negative x equals 2 to the third. Now that the bases are equal, the exponents are equal. Negative x equals 3. Divide both sides by negative 1. X equals negative 3. One-half to the negative third equals 8. That's 2 to the positive third. 8 equals 8. It worked. There was a quick little check there. Number 11. 3 to the x equals 1/9 to the x plus 3. I'm going to rewrite that 1/9. 3 to the x. Now 1/9 is the same as 3 to the negative second. So 3 to the x equals. Now power to a power we multiply. So it's 3, negative 2 times the quantity of x plus 3. Now that the bases are equal, the exponents are equal. X equals negative 2 times the quantity of x plus 3. Set the exponents equal to each other. X equals negative 2x minus 6. Add 2x to both sides. 3x equals negative 6. Divide both sides by 3. X equals negative 2. And you can go through and check that. It does work. Number 12, same thing. 16 is the same as 2 to the fourth, 2 to the x plus 2. Bases are equal. Now the exponents are equal. 4 equals x plus 2. Subtract 2 from both sides. X equals 2. And you can go in and check, and you'll see that it does work. Okay, we are going to stop there for now, and I will see you in the next video.